It is a Tuesday morning in August, somewhere around 8 o'clock. The air outside your house is already heavy and warm, thick with the kind of humidity that makes a cotton shirt feel like a towel. Down below your kitchen floor, 2 feet under the joists, the vents built into your foundation wall are wide open. They have been open all summer because that is exactly what they were designed to do. Bring outside air in, push the stale, damp air out, keep the crawl space dry. Today, right now, those vents are doing the opposite of what you believe they are doing. Every breath of outside air flowing through that foundation carries moisture directly into the space you're trying to protect. And there is published measurement that proves it. The crawl space vent is one of the most documented cases of a building solution that inverts its own purpose under specific seasonal conditions. It does not fail occasionally or in unusual circumstances. It fails predictably in every humid climate, every summer, and the failure is written into the physics of the air itself. Before you understand the mechanism, you need to understand what the failure actually costs you. Because the damage does not stay down there. It moves. The wood that forms your floor system sits in direct contact with crawl space air. That means the rim joists, the band joists, the subfloor sheathing, and the bottom cord of your floor trusses if you have them. When that air stays wet for long enough, the wood responds. According to the Building Science Corporation, wood that stays above 19% moisture content for sustained periods supports the growth of wood-destroying fungi. That threshold is not a rough estimate. It is the number used in wood preservation science and referenced in ASHRAE guidelines for moisture control in building enclosures. 19%. Hold that thought. Below that threshold, you also have your floor insulation, if you have any, hanging between the joists. Fiberglass bats that get repeatedly wetted lose their resistance value and begin to sag. A sagging bat creates an air gap at the top, right against the subfloor. That is the worst place for a gap. It is where heat transfer between your living space and the crawl space actually occurs. Your floors feel cold in winter partly because of what happened to that insulation the previous summer. The two seasons are connected through the physics of moisture, but the most urgent cost is the one that happens above the insulation inside your house. The Building Science Corporation has documented in field studies across climate zones 4 through 7 that a significant fraction of the air inside a typical wood frame house originates from the crawl space. The Building Science Corporation calls this upward movement the stack effect. It pulls crawl space air through gaps in the subfloor and around plumbing penetrations into the living areas above. You breathe crawl space air every day. In a wet summer crawl space that air carries mold spores, the volatile compounds mold produces, and the musty smell you eventually stop noticing because you live with it constantly. Mold on wood framing, degraded insulation, cold floors, reduced indoor air quality. Those are not hypothetical outcomes. They are the documented sequence that Building Science Corporation researchers and ASHRAE Standard 160, the criteria for moisture control design analysis in buildings, have mapped across thousands of field inspections. The sequence begins with a vent that is doing exactly what it was designed to do. So why does more ventilation not simply fix the problem? The homeowner who notices a damp crawl space in June often reaches the same conclusion. The vents need to be bigger, or more numerous, or kept open longer. Hardware stores sell foundation vent covers with thermostatic controls that open the vent wider when the temperature climbs. The logic behind that product is intuitive. Warm air holds more moisture than cold air, so warmer moving air should be better at carrying moisture away. More airflow means more drying. The physics sounds right. It is not right. Not in summer, not in a humid climate. And the reason it fails is precise enough that once you understand it, the intuition permanently inverts. The concept you need is dew point. Dew point is the temperature at which a given parcel of air becomes fully saturated with water vapor. The temperature at which water stops being invisible gas and starts becoming liquid. Every parcel of air has a fixed dew point that depends entirely on how much water vapor it contains, regardless of how warm or cold the air itself is. When you cool that air below its dew point, the water condenses out onto any surface it encounters. On a humid August morning, the outside air might be 83 degrees Fahrenheit, with a relative humidity of 75%. According to psychrometric tables published by ASHRAE, that combination produces a dew point of approximately 74 degrees Fahrenheit. That number is the relevant one. It is the temperature at which that outdoor air will begin releasing its moisture as liquid water. Now you open the vent. That warm, humid air flows into the crawl space. The soil down there, shielded from the summer sun by the floor above it, stays close to the temperature of the earth a few feet down. Building Science Corporation. Field measurements in crawl spaces across the southeastern United States recorded ground surface temperatures ranging from 55 to 63 degrees Fahrenheit through the summer months. Outdoor temperatures during that same period were well above 80 degrees. The concrete foundation walls hold a similar temperature. The steel hardware connecting the joists is even colder because metal conducts heat away faster. The incoming air, carrying a dew point of 74 degrees, meets surfaces that are 60 degrees. It does not need to go anywhere. It does not need to travel far into the crawl space or accumulate over days. The moment that air touches a surface below its dew point, condensation begins. Right at the vent opening. Right on the concrete block closest to where the air enters. Water appears not because of a leak, not because of a plumbing failure, but because the ventilation system is functioning exactly as designed. You brought outdoor air in, and the outdoor air gave you its water. ASHRAE Standard 160 explicitly addresses this mechanism. It identifies the summer condensation risk in vented crawl spaces as a climate-dependent phenomenon that peaks when outdoor humidity is high and crawl space surfaces are significantly cooler than the incoming air's dew point. The standard uses the phrase net moisture addition to describe what happens. The vent does not remove moisture in this condition. It adds moisture, net. This is the finding that practitioners find hardest to accept because it requires reversing a mental model that feels physically obvious. Moving air dries things, except when the moving air is wetter than the space it is moving through. Now, layer the second variable on top of this. Most crawl spaces have exposed soil on the floor. No concrete, no barrier of any kind. Just dirt. That soil is not dry. Building Science Corporation. Researchers measured in unencapsulated crawl spaces that exposed soil can contribute several gallons of water vapor per day. That contribution continues even without visible standing water and even in a week without rain. The supply comes from capillary action drawing groundwater upward through the earth. It is not a storm event. It is a permanent condition. So here is what you actually have. You have outdoor air entering through the vents, already carrying enough moisture to condense on cool surfaces, and you have the crawl space floor emitting additional moisture upward into that same air. The two sources of humidity reinforce each other. The outdoor air raises the crawl space relative humidity, and the soil raises it further. Building Science Corporation. Field data from vented crawl spaces in climate zones 3 and 4 showed summer relative humidity regularly exceeding 90%. That happened on days when outdoor relative humidity was only 60 to 65%. The crawl space was wetter than outside. The vents made it wetter, and the soil kept it wet. At 90% relative humidity, you are 1 degree of surface coolant away from condensation at essentially any moment. The wood does not need to be dripping to accumulate damage. It needs only to stay above 19% moisture content for long enough. And at 90% ambient relative humidity, equilibrium moisture content in the wood will rise well above that threshold without a single visible water droplet forming. You need to know whether this is happening in your crawl space. The tool you need costs between $20 and $30 at any hardware store, and it is called a hygrometer. It measures temperature and relative humidity simultaneously. Place one inside the crawl space, close to the center, resting on a block so it is not touching the soil directly. Place a second one outdoors in a shaded location. Read both at the same time, mid-morning on a warm day. According to Building Science Corporation diagnostic protocols, if the crawl space reading is more than 5 percentage points higher than the outdoor reading during summer months, you have confirmed net moisture addition. The ventilation system is adding humidity, not removing it. You can also look for visible evidence. A flashlight dragged along foundation walls and rim joists will reveal efflorescence, the white mineral crust left behind when water evaporates off concrete, as a marker of repeated wetting. Dark staining on joist wood, especially near the ends closest to foundation walls, signals moisture before mold becomes visible. Insulation bats that have fallen or show sagging were almost certainly wetted repeatedly. These signs do not quantify moisture, but they confirm the pattern. If you see more than one of them together, the Building Science Corporation Field Guide on Crawl Space Diagnostics treats that combination as sufficient evidence to proceed directly to remediation. If you see none of them but your hygrometer reading shows a significant gap, trust the instrument. The instrument does not rationalize what it measures. Now for what you actually do about it. Start with what costs nothing. In summer, close the vents. That is the free intervention, and according to Building Science Corporation guidance on crawl space moisture management, it is the highest leverage single action available in a vented crawl space during humid months. Closing the vents eliminates the incoming stream of moist outdoor air. The crawl space will equalize to a lower, more stable humidity level because you have removed the primary moisture source. If your vents have manual covers, close them now. If they are fixed open, temporary foam blocks cut to fit the vent opening cost nothing and eliminate airflow immediately. The second intervention costs roughly $30 and addresses the soil moisture contribution. A 6 mil polyethylene sheet is available at any home center. Lay it across the exposed soil floor and overlap the seams by at least 12 inches. Following IRC Section 408.3 requirements. Building Science Corporation measurements of encapsulated versus unencapsulated crawl spaces showed that installing even a basic ground cover reduced crawl space relative humidity by 15 to 25 percentage points over a summer season. The sheet does not need to be taped or sealed to walls to provide most of this benefit. Simply covering the soil is the primary action. The third intervention is full encapsulation. A sealed crawl space is the solution that ASHRAE and the Building Science Corporation consider definitive for humid climate zones. It requires a heavy-duty vapor barrier fastened to the foundation walls, all vents permanently blocked, and a dehumidifier or conditioned air maintaining relative humidity below 60%. Energy Star's indoor air package specifications include sealed crawl space criteria. Full encapsulation with a quality barrier and dehumidifier runs near $300 in materials for a small do-it-yourself project, and significantly more for a professionally installed system on a larger space. But the performance difference is documented and durable. Here is what you must not do. Do not install more vents. Do not open the existing vents wider. Do not add a powered exhaust fan to pull more outside air through a vented crawl space in summer. Every one of those actions increases the volume of humid outdoor air entering the space and accelerates the condensation described above. Building Science Corporation guidance explicitly flags this as a counterproductive intervention in summer humid conditions. More ventilation in a humid crawl space in August is not aggressive drying. It is accelerated wetting. The physics do not change because the intention is good. A homeowner who adds vents in response to visible moisture is repeating, with more hardware, the same error that produced the moisture in the first place. The Building Science Corporation documents this pattern across hundreds of field visits. More effort in the wrong direction is still the wrong direction. The vents were designed for a different problem in a different climate. They were developed for conditions where summer air is dry and the primary threat was soil moisture rising unchallenged into wood framing. In that environment, ventilation works. Dry outside air does carry moisture away from the space. The code was written and the building practice spread nationwide before systematic field measurement had been done in humid climates. In those regions, August humidity is not a rarity. It is the baseline condition. The Building Science Corporation's research program through the 1990s and 2000s documented the geographic mismatch between the design intent and the climatic reality in regions where the crawl space vent was never calibrated to perform. The crawl space under your house is not broken. The theory that governs it is. What felt like airflow felt like drying. What the instrument showed was net moisture addition. The two things that seem identical from outside the space are opposite in their effect. Close the vents, cover the soil, let the crawl space be still. The fix is a subtraction, not an addition. In a space built on the premise that more air means more drying, that inversion stays invisible until you know where to look. The vents were built to help. In August, help looked exactly like harm. If you have a crawl space, go down there with a hygrometer this week and compare the reading to the outdoor humidity. Tell me both numbers in the comments.